Welcome to our discussion on the multiplication of whole numbers. You can see not a lot of objectives. We're just going to multiply, and we're going to look at some word problems. Well, first thing to realize is that multiplication is really just a shortcut for doing repeated addition. 5 times 6 is really the same thing as just adding 6 together 5 times. So that tells us that multiplication is going to be strongly related to addition, and it is. In fact, a lot of the rules that we can and can't do with addition kind of roll over into multiplication. One of which is the commutative property. We know that if we have a bunch of stuff, in this case we have 12 things, we could order them in 3 rows of 4. 3 times 4 equals 12. But we could also make it 4 rows of 3. 4 times 3 is 12. That's the commutative property, where A times B is the same thing as B times A. Well, because multiplication is built out of just repeated addition, it also follows that A plus B is the same thing as B plus A, right? We can do 3 plus 4 and get 7, same thing as 4 plus 3 and get 7. Does not work with subtraction or division, right? Because 3 minus 4 is negative 1, 4 minus 3 is positive 1. And then, of course, 3 divided by 4 is 3/4. 4 divided by 3 is 1 1/3. So the commutative property only works with addition and multiplication. Now, to become really good at multiplication, you need to know kind of some of the basic one-digit facts from memory. You should just have them memorized so you can go quickly. Obviously, if you're doing all this stuff in technology, you don't need that so much, but it still will help you when you want to do your estimate, because just like any other math operations, it's always a good idea to estimate what our answer should be so that when we do things with calculators or whatever kind of technology we're using, we can kind of check and make sure that our answer is what it should be, that it's at least in the same scale, right? Kind of the same factors of 10, if you want to think of it that way. But in any case, the single digit multiplication rules that you should have memorized are as followed. Of course, if you multiply anything by 0, it's 0. If you multiply anything by 1, it's itself. And then a lot of the others are pretty simple and easy. It'd be great if you could have kind of your times table memorized. That helps save you a lot of time, but it's not necessary. And if you are kind of working on those and trying to memorize a lot of those, the ones that kind of trip people up the most are these 6 here. 9 times 8, 7 and 6, and then 8 times 7 and 6, and then 7 times 6. So basically things that involves 6, 7s, 8s, and 9s. Well, there are some patterns that help you. So for instance, when you're multiplying by 9, the first digit of the solution is always 1 less than what you were multiplying by 9. So 9 times 8 equals 70 something. 9 times 7 equals 60 something. 9 times 6 equals 50 something. And then, of course, the last digit, the easiest way to kind of know what it is that solution, those two digits have to add up to 9. So 7 plus what is 9? Oh, 2. 6 plus what is 9? Oh, 3. 5 plus what is 9? Oh, 4. Or you could just kind of have them memorized, right? 9 times 6 is 54, and so on and so forth. 8 times 7 is 56. That one is kind of easy to remember because it's 8, 7, 6, and 5. The only difference is it's 56 instead of 65. 6 times 8 is 48. That one kind of rhymes and helps you with that. And then 6 times 7 is 42. There aren't a lot of easy ways to memorize them other than just kind of work with them enough times and they kind of stick. All right, when we have to do larger numbers, it still just comes down to doing simple, basic one-digit multiplication, and then you just kind of do it in stages, right? So 34 times 2, you line everything up, right? You got the 1s lined up and the 10s lined up, which, of course, we don't have any here. And then you do the math. 2 times 4 gets us 8, and then 2 times 3 gets us 6. But it's not 6, it's 6 tenths, so it's 60. 60 plus 8. So oftentimes what you'll do is you'll do 2 times 4, and you'll put an 8 here. Then you'll do 2 times 3, and you'll just put the 6 here in the tens spot, and there's your 68. Or sometimes you'll do 2 times 4 and put an 8, and then you go 2 times 3, and you'll put a 6 below it, right on kind of the next line, because you want to leave that space sometimes for other operations and then know that, oh, okay, that just comes together as 68. Whatever works for you, but of course, technology works even better. So we can do all these things in technology, but you still want to do some checking first, right? So before you slap this into technology, you go, all right, 28 times 3 is the same thing as 30 times 3, which should be roughly 90. Slap it into your calculator and get an answer of 84 and go, yep, that's close to 90. Same things if we want to have, bigger things, bigger numbers. We should still always try and estimate them. Now, multiplying 2 and 3-digit numbers by 1 digit can be done mentally. When you have to start doing bigger ones, it can get a little trickier, but there are some tricks that can help along the way. And it really comes down to always estimate, so you know what your answer should be, and then really just throw the rest into technology. That's the best way. If you want to do these things by hand, by all means, it's very easy. It's the same technique. You always stack everything, and then you multiply accordingly. 4 times 9, right? 9 times 4 is 36. So here's my 6. I'm going to carry a 3. And then 4 times 8 is 32. 32 plus 3 is 35. So 356 is just this bit. But now I got to move on and do the 20. So this basically means now 20 times 89. Well, that's the same thing as 2 times 89, but everything's going to be multiplied by 10. So when I do 2 times 9 and get 18 and carry the 1, instead of putting the 8 here, I know that it's really multiplied by 10 because it's not times 2, it's 9 times 20. So I scooch it over and put it here in the 10 space. That's my first answer of 8. The 1 comes up here. 2 times 8 is 16, plus 1 is 17. I get 178. And that 178 is what would happen if you took 89 times 20. Then you add those two things together to get your final result, and there it is, 2136. Okay? But we want to definitely check it with our rounded answer of 20 times 9, right? And so on and so forth, and see that we get roughly the same answer both ways. Okay, a 3-digit number, same thing. We're just going to repeat the process where when you multiply by the 1's digit, it goes here. When you multiply by the 2's digit, it gets moved over into the second space. And when you multiply by the hundreds, right over in the third, I think I said 2's digits instead of 10's, then it moves over into the third space. And then we could do this with 4 digits, 5 digits, 6 digits, and so on. So it doesn't matter how big the number gets, that same little pattern always holds. Now, there are some shortcuts that can help you with multiplication. Many of them are very, very complicated, would make your head hurt just trying to think about them. But there are some really easy ones. Like, obviously, if you're going to multiply by any power of 10, you're just going to add zeros, right? So if you multiply by 10, you add 1 0. You multiply by 100, you add 2 zeros. You multiply by 1,000, you add 3 zeros, so on and so forth. And the same goes for multiplying by numbers that end in zeros, right? 26 times 20 is really the same thing as 26 times 2, which is 52, but that 0 on 20 puts a 0 on our answer, and it's 520. And that also works if both things have zeros, right? 23 times 2 is just 46, but we had 3 total zeros, so we slap 3 total zeros on the end of it, and there's our answer, right? 1,000 times 100, well, 1 times 1 is 1, and then how many zeros do we have? We've got 5 of them. So that's the nice thing about powers of 10. That's the other reason why the metric system is so nice, because you're always dealing with powers of 10, which, as we see, makes the math really easy. Okay, some application problems. If a mason works for 40 hours, earns $18 per hour, we can multiply the number of hours by the hourly wage to find the total amount earned, right? If an electrician needs 12 pieces of wire that are each 18 inches long, and we need to figure out how much total wire they need to buy, right? 12 times 18, so on and so forth. So it's really easy to use multiplication with technology, but you definitely want to estimate each time, right? 40 times 20. Well, 4 times 2 is 8. Add 2 zeros, 800. The answer should be somewhere close to 800, which it is, right? 12 times 18. So this would round to 10. This would round to 20. 10 times 20 is 200. 216, right? So you always want to estimate these things. All right, that's all I got for you.